ಏನಿಲ್ಲ. ಏನಮ್ಮ?
Okay. Let us begin today's session with a prayer. Everybody sit straight, join both the hands. Om Gurur Brahma, Gurur Vishnu, Gurur Devo Maheshwaraha, Guru Sakshat Parabrahma, Tasmai Shri Gurave Namaha. Akhanda Mandalakaram Vyaptam Yena Characharam Tatpadam Darshitam Yena Tasmai Shri Gurave Namaha. Narayana Samarambham Shankaracharya Madhyamam Asmadacharya Paryantam Vande Guru Paramparam. Sri Gurubhyo Namaha. Welcome all to the science session. So in today's session, we will be learning about the physics concept. So I hope you all have the materials with you. The materials required for this model are 1 paper cup and then 1 kg cardboard, scissor, color sketch pens, and then glue, Fevicol. I hope everybody has the materials with you in handy. Now I'll share the screen. So we'll explain about the concept and the steps also. So today's toy model is a rolling friction. Wait. So at the end of the this session, you will be learning this concept, science concept. What is rolling friction? So can anyone tell me the example of rolling action in your daily life, where you can see the rolling, why the rolling is required, what happens if you don't have a rolling? See here in the figure I have shown a table on which a wheel is, you can imagine the circle as a wheel, okay? A wheel when placed on a table, what happens? Or imagine one rectangular box is placed on a table. What is the difference between those two scenarios? Can anyone tell? Megha? if you place a rectangular box on a table, what happens? Is it easy for you to move the rectangular box or the wheel? Is it easy for you to move the wheel on the table?
It's easy to move the wheel.
Wheel. Very good. Who answered this? Yes. What's your name?
Aradhya.
Aradhya. Very good. Yes. Why? Why it is easy? Why do you say so?
It is circle. Because it's easier.
Why? Can you tell me the reason?
We must push it. The circle, we just need to push it to go by itself.
See, simple reason is, for if you imagine a rectangular box, I'll show you that. See here?
Ma'am.
Suitcase. Yes, yes. Datri, tell me.
In rectangle box, why it cannot roll means it has corners. That's why it cannot roll, and circle don't have corners. That's why it can roll.
That's also good observation. Very good. But I want you to know how much force is required for a rectangular box and how much force is required for a wheel. Do you will you apply more force for a wheel or a rectangular box? Which one?
For wheel.
For wheel, you will apply more force to push the wheel across the table. No, right? See, pushing the wheel is easier, right? For example, if you take a bangle, okay, and if you take some rectangular shape thing, for example, matchbox, okay, place this bangle as well as matchbox on your table. Try to move it. For which object you have to apply more force?
Rectangle.
Yes, correct. Now you are right. Why? Can you tell me the reason? Can anyone tell me the reason?
Because rectangle has corners. That's why we should put more force.
Yes, yes. See, one more thing. Rectangular box. For example, in this figure, you can find that 25 kg suitcase box, right? So that suitcase, it is touching the table at all the points. Okay. Yes. All the points of this rectangular suitcase is touching the table. So, if you apply more force only, you can move that 25 kg suitcase. Otherwise, beside that, you have one more suitcase which has two wheels. Okay, circle. So, the point of contact is only two. Only at 2 points you have a contact with the suitcase. So, it is very easy to move with less force. You can apply less force and you can move the suitcase. Okay. So, rolling and friction is a thing which we are going to study in today's class. The definition is like this. Rolling friction or rolling resistance is the force resisting the motion when you are rolling a body on the surface. Okay, for example, see, you are here when you are cycling, when you are pedaling, that is the applied force. You will be applying the force. And what is the friction? Can anyone tell from this figure, with the help of this figure? What is the friction? What is the force that applies, that is against you? The air resistance. See, when you are pedaling the cycle, you should apply more force, right? When you have more air, wind against you. Correct? For example, when you are moving in a slant position, in sliding, this is when you are moving in a straight road, what are the frictions that you come across? The air resistance that is shown in this figure. Okay. So applied force is nothing but what you pedal. So rolling friction is nothing but the force which resists the motion of the object, the circular object. Okay. So in this toy model, we will be we'll make a toy model which is a circular shape, okay, which is a wheel shape, and yes, see, this is a toy. Wait 1 second, I'll stop sharing. Let me. So now I'll show. Now let us do the toy model one by one. This is the first step. The first step is you have to draw the figure. So, and before that, you need to measure your cup shape, your paper cup. No need. See, you have take a paper cup and draw the circle, the bigger circle near the mouth of this monkey is written inside that paper circle. Using your paper cup only, you have to draw this circle. The diameter of the circle is nothing but the diameter of your paper cup, whatever paper cup you are using. Few students may be using small, medium, or bigger. So whatever it is, the diameter of this monkey should be within that paper cup diameter. So you can take your time, draw the diagram.
Okay.
I hope everybody can see this. So let me know once you draw this. This is the first step. Then you have to cut, and the second step is the pink box. There you have to cut the monkey, and 3 sides of the like you have to leave some space, at least one half a centimeter you have to leave. You should not cut the entire thing, otherwise you will not be able to paste it properly inside this paper cup. You can do different figures also, like Joker or any other toys, any other character, animation character of your choice. This is very simple toy model. Here I am focusing on the physics concept involved in this toy model.
Done, ma'am.
Yes. Okay. Let's wait for others also. Okay. Yeah. Good, good. Who has completed?
Ma'am, can I cut it?
Yeah. 1 second. Hmm. And when you are cutting it, be careful, okay? Near the legs part, you have to leave half an inch, 0.5, 0.5
Near the
centimeters.
hand also.
And near both the hands also.
ಅಮ್ಮ ನಿನ್ ಕೈಯಲ್ಲಿ ಆಡ್ಸಿ ಹಾಯ್ ಅಂತ
See, before drawing only, before cutting it into a circle only, you have to leave that space near the two legs. Be careful with that, okay?
It is main important.
Any doubts you have? You can ask me.
No, ma'am. I'm still doing.
Yeah, do it. Anyone completed?
No, ma'am. No, ma'am. I'm still completing.
Okay, do it, do it.
Done.
Yes, yeah, tell me. Show
Ma'am,
me.
I'm not done.
Okay. Ah, very nice. Yes. What's your name? It's written.
Ramakrishna and Megha.
Ramakrishna and Megha. Okay, you have done?
Yes, ma'am.
Okay, show it to me. 1 second. I'll just stop sharing. I'll maximize your screen so that others can see your toy model. Spotlight. Yes. Good. Okay. No, you should not paste it like that. See? Hollow thing. See, you should take a paper cup. That step I have not mentioned actually. After drawing the monkey, see 1 second. I'll just spotlight.
Ma'am, we didn't paste it. We just kept it.
Okay.
You told us to leave this gap, no, ma'am.
Yes.
Folded
See,
that and kept it.
okay. You have not pasted, is it? Then it's okay.
He has pasted.
So, see, before pasting it, you need to measure the paper cup. So, like, I think 2 inches I have taken. 2 inches, you have to cut the paper cup. Okay, approximately. And then you have to paste it.
Okay, ma'am.
Ma'am, could you share your screen? Ma'am, can you check mine?
Yeah. Show it to me. What's your name?
Adya.
Adya. Adya. Yes.
Adya.
Aradhya. Okay. Yes, nice, Aradhya. Very nice. So, did you now you can check it. You have to roll it on a flat surface and see what is opposing. See the force you are applying the force with your fingers, okay, and it moves for some distance and then it stops. Why it stops? Because of the friction. Okay, friction acts as a opposite force and your this wheel, you can imagine this as a wheel. Okay, your toy model stops because of friction. You have to roll it on a flat surface table. So you have to play with this toy model and understand the science concepts. So we have the formula. Here I have shown it, right? In the previous slide, I have shown it, the formula. So those formulas, you will be solving it when you go to your higher classes. See,
Ma'am,
this is the formula. FR is equal to mu R M into G.
ma'am, is it like this, ma'am?
Ramakrishna, yes, show it to me.
Just a minute, ma'am. Should we put gum inside?
Yes, to the this you have left some space, right? Like 1 inch for that monkey. In that space, you have to apply the Fevicol and then stick to this cup. You have to fold that space. See, near the leg of this monkey, I have applied applied the Fevicol, and you have to stick that inside this paper glass.
Okay, ma'am. Ma'am, should we stick it?
Yes, you have to stick.
Ma'am, I finished.
So that cut the paper cup and
Ma'am, I finished.
yes, sure.
Ma'am, should we
Wow,
stick?
Dhatri, very nice.
Ma'am, should we stick the old invitation card?
Yes. Now that monkey on the invitation card, you have drawn monkey, right? And you have cut it into this shape, and the legs and the hand part you have extended, right? For that extended part, you have to apply the Fevicol or gum glue, and then you have to stick to the this paper cup. The final step is you have to, after sticking it to the paper cup, see, you can see your toy model will be ready. Yes, Dhatri's toy model is looking very good, colorful. Show it 1 second. We'll have a closer view of your toy model. Oh, here, since I'm sharing the screen, now you can show it. Wait. Yes, butterfly, yeah? Very good. Okay, good.
Yes, ma'am.
Very nice. Yes, that's what I told you, right? You can do your own favorite cartoon characters and learn the science behind this toy model. Every toy model will have a science concept behind it. So whenever you look at a toy model, you should try to analyze how it works. That is how you develop a scientific attitude. How many of you want to become scientists?
Ma'am, I want to become teacher.
Very good. Okay, good. And Aradhya? What you want to become in future?
A scientist.
Very good. So if you want to become a scientist, you have to analyze how it works, what is the science concept, like that. You should be curious to know.
That's science. Another science like pouring potions like this. Usual potions, right? That.
Oh, chemistry, is it?
Yeah.
Ma'am, can you share your screen?
Yeah. Sorry. Okay. This one you want, right? Somebody join now. What's your name? Introduce yourself. Hari Om. Aradhya left. Those who have completed, post your toy models in the group, WhatsApp group. Okay. So that others also will be motivated to attend the classes and learn the science behind those toy models.
223 ಜನ ಇದ್ದಾರೆ, ಜಾಯಿನ್ ಆಗಿರೋದು 3 ಜನ.
Preserve all your toy models. So whenever we have science stalls, see this, I think everybody are aware of Light of the Self Foundation. So every year we'll be having a science stall during Krishna Janmashtami celebrations. So you can exhibit your toy models, and you'll be having many competitions like Bhagavad Gita circle is there, art circle is there, science circle, quiz circle. You can participate whenever you are free and win exciting prizes. And for elders also, for your parents, they have some Vedanta study circle classes are going on. So every week, spirituality, it is related to spirituality. And for elders also, Bhagavad Gita classes, Lalita Sahasranama classes, everything will be there. So it's completely free. This is an NGO. Like science classes, art, Veda classes are also there, chess. So we have many other classes, and all the classes are free of cost. So interested kids and parents can join and gain the benefits. So you can Google it, like Light of the Self Foundation. You can search about the events that we are doing it. And everything, most of the classes will be online only, online activities. We have actor circle also. So where we encourage kids to participate in various like Puranic characters. Like we'll be more focusing on Vedanta, spirituality, and Bhagavad Gita, Ramayana, like that. We'll be celebrating few festivals like Krishna Janmashtami, Ramanavami, so on those days, the kids will be performing some drama or some skit related to the spiritual ethics, moral ethics, like that. So you can encourage your kids whenever they are free. You can engage them into different activities and gain the.
Ma'am, will that be online, ma'am, for kids?
Yes, online only. Sometimes the practice, the drama practice and everything, they will include, they will group, and they will call at least for 4 to 5. So it depends. Where if you are nearby to the volunteer, they will call and they'll arrange everything. But this is a very good platform. You can utilize this, and so that the kids will be exposed to our spirituality, Vedanta, and they'll know the importance of this.
Yes, yes, ma'am. Okay. I'm Sri Ranjini, ma'am.
Oh, Sri Ranjini. Okay.
Yeah.
Okay.
Yeah.
Your daughter, huh? Datri.
Yeah, Dhatri. Yeah.
Okay. Okay.
Hmm. Yeah.
Ma'am,
Very nice. Yes.
will you put it in the group?
What regarding
Class details, ma'am.
this class details?
Yes, ma'am.
Okay. Oh, you are a new joinee, right? Okay. Every month, first Sunday of every month, usually we will be having one science class. So in that science
Okay.
class, you will be doing one toy model and learn the science behind the toy model. This month, I have kept it on third Sunday because we had some residential camp conducted by our Prabhuji, like the Light of the Self Foundation. Uh, every year they conduct residential summer camps. So I was part of that summer camp. That is the reason we didn't have on first Sunday. Or else every month first Sunday you will have this science class 6:30 to 7:30. Only in case of some emergency situations or yeah. So kindly take the benefits of these classes so that whenever you come across these concepts like rolling friction, I told you, right? These concepts you have to study in your 8th standard, 9th standard, and 10th standard in detail. So whenever you come across those concepts, see, because the visualization, the toy model also helps you to remember those science concepts instead of memorizing it. See, you can't memorize lakhs of formulas, right? So, through this visualizing and touch, feel, shabda, sparsha, rupa, rasa, gandha. So, through all these senses, if you play with this, then understanding the concepts and analyzing will be very easy for you.
Okay, ma'am.
Okay. So, try to attend one class per month, right? So, try to attend the classes and take the benefits of this. Which
Okay,
class you are studying in?
Fifth, ma'am.
Fifth, okay. Which school?
Prerna Waldorf School.
Okay, good, good. So, for this class, you can watch the recording and try the concept. I'll share the YouTube link of this class. Okay. So, I think you have joined just 10 minutes before, right?
Yes.
So, here, this is very simple toy model actually. The concept is rolling friction. Just for your sake, I'll just explain it. Okay. I think here, yes. Why do you need friction? What is friction? Wow. What is the, see, those concepts I have explained in this slide. What is the science behind this toy model? So, when you in practical life, why do you use a wheel? That is explained in this figure. So instead of using what is the, so the force applied will be very less when you use wheels. So here I've used the roll paper cup. I've used the toy model to make you understand the rolling friction. Okay, we'll place this paper cup, the toy model, on a flat surface and apply the force using our fingers. Okay, when you apply the force, see the paper cup rolls for some time and then it stops at some point. Why it stops? You have to analyze that. So the paper cup will, for this paper cup, these all the forces that will be acting on this paper cup. Applied force is through, so you can observe this cycle. Example, the applied force is nothing but you are applying force from your fingers for this toy model. Okay, when you apply a force, you have all these forces. Normal is perpendicular to this toy model, normal force, and you have one more force, frictional force, that is against, that is towards the gravity. You know, right? Gravitational force, acceleration due to gravity. And one more force which is opposing, which is making your toy model to stop. How this toy model is stopping? Because of the air resistance. That is the force acting from the other side. Here I am applying the force using my fingers. And which is the force that is stopping the toy model to rotate? That force is nothing but your air resistance. Okay. And the friction is nothing but your gravitational pull towards the earth. So all these forces are acting on this toy model. And that you can learn from this formula. FR, FA, force applied is FA. So using this formula, you will be able to calculate and find out how much force is required for you. So these type of problems you will be solving in your higher classes. So 8th, 9th, 10th, high school problems, you will be using these kind of formulas. So by attending these classes, when you look at these terminologies, you will not get scared, because practically you will be playing with the toy model and understanding the concepts here. Rolling friction, FR is the rolling friction. M, mass of this toy model. See, mass also is dependent on the how much force I have to apply. If this mass is very heavy, if the mass of the toy model is heavy, then how should I apply more force or less force? Can anyone tell? Mass of this object is heavy means how much force I have to apply? More or less? From this formula itself, you can see. If mass is more, M is more, then more force I have to apply.
Okay.
Okay, is equal to mu r mg. G is nothing but acceleration due to gravity. Everybody know what is gravity, right? When you throw any object, what happens to that object? It comes down. When you throw any object, for example, say this yo-yo, I'm throwing it up. What happens? It's coming back towards the ground, towards the earth. That force is nothing but acceleration due to gravity, G, and weight of this object, and then mass. So all these terminologies you will learn in your higher classes. So this model may be very simple, but the concepts are very, very important. So everybody completed this toy model? Hope it was very easy. See, these are all steps we have followed. First, we using the paper cup. The paper cup which we have used for this toy model. I'll draw a circle. This is the first step. I'll draw a circle on the kg cardboard. Okay, this one kg cardboard or old invitation card I have used. And then I've drawn a monkey inside the circle. And then when I'm cutting the monkey, I have to leave near the legs and near the hands, half an inch I will leave. And then I will bend those extra parts and attach to this circle shape, wheel shaped paper cup. So these are the only 3 steps that we have done in this toy model. Just for the new students' sake, I have covered everything. So hope you understood, Tejo.
Yes, ma'am.
Yes. So you do it when you are free. You have holidays, right?
Yes, ma'am, I will do it.
Yeah. Do it and post it in the group. Okay?
Okay, ma'am.
Yeah, sure. So now you can play with the toy model and learn the science concepts and try to remember the formulas. That is the main aim of this class. So, Pavan Nanduri, Ramakrishna, completed?
Ma'am, my name is Sarvani, ma'am.
Sharvani, yeah, okay. Sharvani completed?
No, ma'am.
Which step you are in?
Almost completed, ma'am.
Okay, do it. Megha and Ramakrishna, I think they have left. Okay. So those who have completed, you can send a pic. You can send your toy model pic, and I think the class will end with a. Let me end the class session with a close. Yes, very good, Megha. 1 second, I'll just take a snapshot. Yes, show me those who have completed. Yes, Megha.
ಅಪ್ಪ ನಂಗ್ ಕೊಡು ಅಪ್ಪ ನಂಗ್ ಕೊಡು ಬಿಸಾಕ್ಬೇಡ
Very good. So did you test? Did you test? As I said, kept it on the very good. Dhatri's butterfly. Yes. Good. Yes, very good. Okay. Yes. So let us complete the session with a closing prayer. Very good. Dhatri, Ramakrishna, Megha, very good. Sharvani, right? You post it in the group.
Okay, ma'am.
Okay. So let us complete the session, end the session.
Ma'am, actually, Sarvani and Samanvita, ma'am.
Oh, both are? Okay.
Yes, ma'am.
Post both your toy models on the WhatsApp group. Okay.
Okay, ma'am.
Oh, good. So nice of you. Kindly attend every class and take the maximum benefits of this. So let us close the session with a prayer. Asato ma sadgamaya tamaso ma jyotirgamaya mrityorma amritangamaya. Om Shantir Shantir Shanti. Purnamada Purnamidam Purnat Purnamuduchyate Purnasya Purnamadaya Purnameva Vashishyate. ನಾನೆಂಬುದು ನಾನಲ್ಲ ಈ ದೇಹ ಮನಬುದ್ಧಿ ನಾನಲ್ಲ ಸಚ್ಚಿದಾನಂದಾತ್ಮ ಶಿವನಾನು ನಾನೇ ಶಿವೋಹಂ ಶಿವೋಹಂ ಶಿವೋಹಂ. ಆತ್ಮದರ್ಶನಂ ಬ್ರಹ್ಮದರ್ಶನಂ ಬ್ರಹ್ಮದರ್ಶನಂ ಸತ್ಯದರ್ಶನಂ. ಲೋಕಾಃ ಸಮಸ್ತಾಃ ಸುಖಿನೋ ಭವಂತು. ಲೋಕಾಃ ಸಮಸ್ತಾಃ ಸುಖಿನೋ ಭವಂತು. ಹರಿ ಓಂ ತತ್ಸತ್. ಶ್ರೀ ಗುರುಭ್ಯೋ ನಮಃ. Hari Om to everyone. Let us meet
Hari Om, ma'am.
the next session. Hari
Hari
Om.
Om, ma'am. Hari Om, ma'am.
Hari Om. So I'll end the recording.
Hari Om.